Okay, so today I'm going to give you an overview of LaTeX using overleaf.com. I found that it's very easy to set up, and you can use third-party IDEs if you'd like. The code should work either way, but this is just easier for first-time LaTeXers to dive into code. Okay, so the first thing you're going to want to do is make an account. I've already made my account, and we're going to want to create a new project. So whenever I select new project, it gives me a variety of options for templates. However, we're actually going to go with a blank project and see what that looks like now. I'll name it My First LaTeX Project. All right. So on the left of the screen is where I write my LaTeX code or markdown language. On the right is what the compiled result will look like as a PDF. So let's change this. My name is Paul Martin. Okay. Now let's look at the structure of this document right here. First, there is a begin document and an end document here. And anything I write in here shows up over here. For example, let's write something. This is where I write my introduction. Right? And then I come over here and I press recompile. Or here, you can do Control Enter, and it'll do the same thing. Okay. So anything that does like this, where it says begin this, end this, is what they call an environment. And when you read online, whenever they're talking about an environment, they're saying, you know, /begin whatever, /end whatever. And then anything you write between those two things is in that environment. So there are different ways of structuring these documents, and one of them is with these sections. So I can do another section right here, and notice that Overleaf is suggesting things to me. So I can press tab and it'll auto-complete it for me. So let's do methods right here. So another way of structuring documents is with paragraphs. So I can do paragraph, and it'll actually fill it in like this. And then pay attention to this right here because it should indent it. Ah, yes, it says, oh, I see. This is a paragraph. Okay, I'll be sure to indent it. So that's how you can structure some of these documents. Aside from sections, you can also have subsections. This is a subsection. When I hit compile, look how that changes. Okay, so now I'd like to show you how to do some basic math. In order to do what we call inline math, where it's math inside of an equation, or sorry, inside of a sentence, we use these dollar signs. So let me actually write something substantial here, like x is my variable for position. All right, recompile, and let's see what that looks like. All right, and there we have it. And see, notice that the x looks a little different, like it's properly formatted for math. Now, very often we don't want it to be in a sentence. We want it to be separate. And so instead what they'll do is they'll use two sets of dollar signs. So something like this, x equals y. So notice what happens when I compile this. It sets it to the side. However, this is no longer standard practice. And the new standard practice is actually to use an equation environment. So something like this. begin equation. And so notice that there are two versions of equation with an asterisk, but I'll just do the regular equation for now. And then notice that overleaf auto completes it and automatically throws in this slash end equation. And whatever we write between these two is what will show up. So now whenever I write y equals, or x equals y, I do Control Enter. That compiles it. So I'm going to blow this up a little so we can look at it. Notice one, there is now an equation number here. And so that will vary by where you put it in the report. And it's nice to have your equations automatically numbered like this for when you're referring to them. So let's actually delve into what I can do with these equations. And I'm mostly going to be working in this equation environment. And let me find just the right spacing where this looks nice. So let's try and do something like Maxwell's equations. So can I use a nabla? So I notice nothing is highlighting here. And that tells me that I don't have the package equipped to actually render a nabla. But let's just see what happens. It's probably going to give me an error. No, it did. Okay. It gave me that. So let's do, let's make B a vector. Vec, I think is the command for that. Vec B, and that should equal 0. And so this should be a divergence, so it should be multiplying it. I'm not taking the gradient. So to do that, I'm going to do a C dot, and that adds in a multiplication sign, or a multiplication dot. See, and notice that looks so nice right there. And you can add all sorts of fancy stuff to make it look even better. So let's add, but very often, when doing these equations, I want a sequence of equations. So if I'm going to do the other Maxwell equations, then what I want is, instead of an equation environment, I want an align environment. Sorry, align environment. So let me get rid of the equation environment that I had. And I'm going to copy this, paste this. Let me just get rid of that. I should have cut it. Okay, so if I compile it just like it is, it'll look exactly the same. Oh, wait. No, okay, so now we've run into, I don't have the package to compile this align environment. So up at the top, see there's already a default use package here. I'm going to use the same syntax and include a math tools, or AMS math I think will work. But let's do math tools. I think math tools is a wrapper for a bunch of these math packages. Let's see if this works. It does. Okay, so you ask, what's the nice thing about aligns? And the nice thing is that I can do, so 2 backward slashes indicates that there is a line break to LaTeX. So I'm actually going to copy this, because what I'm going to be doing now is very similar. It's Maxwell's equations. So let's do E, and let's do charge density rho divided by, and actually, oh, yeah, so rho, and then I know there should be an epsilon naught, but I'll come back to that in just a second. Okay, so you see how these two are aligned like that. I can align them even better, and I'll show you in a second how to actually do that. But the first thing I want to show you how to do is fractions. So there's actually a separate command for fractions, and you'll notice this pops up. There are 2 sets of brackets with this frac. The first goes in the numerator, the second one in the denominator. So what I'm going to do is put rho in the numerator and epsilon naught in the denominator. So let's see how that looks. Very good. Okay, so now we have a slight misalignment though between our equations. So I can align them in a variety of different ways. I can have them aligned at the divergences, or I can have them aligned at the dollar signs. Or sorry, not the dollar signs, the equal signs. So the way you would do that is with an ampersand. Ampersand makes them line up. So let's see how this changes. It should align them at the nablas. See, now they're lined up right there. And actually these line up as well. And that's more useful when you have more things on a bunch of different lines. But it's nice to be able to line up things like that. So it looks very pretty. Okay, so something we can do to make our vectors look a little more professional is, instead of using the vec, we can use mathbf and just make it bold. So when I compile this, much better. And I'll do the same for E. There. Oh, that didn't. Oh, I see what happened. There we go. There, that looks really good. So now notice that it put numbers on both of these. Something I can do is to take the numbering off of just one of the lines. I can do no number. So that way I can refer to this equation block as a whole. Now, something I also want to do is there are 4 Maxwell equations, so I'm going to typeset them and space them out a little so it looks nice and it's in one code block. So okay, so now we're going to finish off Maxwell's equations. Let's add this quad in to give it a little space, then start typing it out. So we do another nabla, and then now instead of the C dot, we'll do a times symbol for a cross product. And mathbf b. And now what is this equal to? So we have a mu, not. So this is something else I'll point out. I'm going to go ahead and compile this so you can see what it looks like so far. But I'm gonna naively type these parentheses like this, and so I'm gonna do a mathbf j for the current. I'm gonna do epsilon not. Okay, I found my error. It was right there. I didn't have enough brackets. Okay, so now let's see what this looks like. Okay, so, well, I didn't add an addition symbol here. Let's see. So the thing I noticed is that the parentheses don't look to be the right height. Now, there's an easy way to correct this, and that's with this. So you do a left, and then a parenthesis like that, left parenthesis. And then on this side, do a right closing parenthesis. And now, it looks much better. Okay, so we're going to do something similar for the curl of E. Let's come down here and do another quad. And the quad just adds some space. And actually, there's not enough space on this top one, so I'm going to add a double quad, which is you just do a Q like that. So now let's type out the curl of E. mathbf E. Now what does that equal? That is the negative partial derivative of the magnetic field. So that's fraction partial mathbf B. And then on the bottom, it's a partial T. Let's see. Perfect. Okay, that looks good. But now I want these two to line up, so I'm going to add in more ampersands to make sure they line up, just like I want them to. Wait, that didn't do what I wanted it to. Okay, so I have it decently lined up now. I changed the location of the ampersands. And sometimes these alignment issues just take some finagling to get right. And that's really all I'll say about that.
So I thought as a good example project to better learn LaTeX, we can take this document that was written in Microsoft Word, it's a lab report template, and we can convert it into LaTeX. Let's get started. Okay, so the first thing we're going to do is section off the document properly. So this is what it looks like by default. One thing I don't want is I don't want this 1. And so the way that I get rid of that is I put a star after it, and then watch what happens when I compile it. It gets rid of that. Okay, so we have a handful of different sections that we want in this document. But first, another thing I'm going to do is I want the entire page to be used. Notice the very large margins so far in this document. Now, I can import a package called full page that will let me use the full width of the page. So now I'm going to copy and paste these different sections. So the first section is like this. Then enter in the next section. Okay, so now we have everything copied and pasted into here. So all the sections will look just like this. Now another thing I want in our lab report is this nice rounded box. So there is a package in LaTeX called the T-color box that I'm going to use to replicate this. So in order for me to use it, I need to do the use package T-color box. And the syntax is going to be an environment. So it goes T color box. And now notice this isn't like a commonly used package, and so it's not auto-completing it for me. But that's okay, because it works all the same. So now I'm just going to copy and paste this whole thing, and then I can get rid of the equations because I don't need them. But and it looks like gobbledygook when I do copy and paste them. Most of this stuff I'm going to want to redo in nice LaTeX format. Okay, but let's see how that looks. I think that looks very nice and professional, but we do want to redo the mathematics. Okay, so let's examine first this inline equation and see how we can format this to our liking. That goes right here. So we're talking about force on a particle, not. So this is an inline equation, so we're going to use the double dollar signs like this. And I'll make it bold. And I'll do a force on particle 0 equals the charge of particle 0 times the electric field on it. Okay, let's see how that looks. And there's a subscript that we need to add, but I'll wait just a second to see how this looks. Yes, that looks nice. It didn't look very good zoomed out, but it looks fine. And I'm going to want to add a space right here, so that looks decent. Okay. Now let's add that subscript. So the way I'm going to do that, because notice if I just add a subscript the usual way and I say all, it's going to format it to look like it's math. See how it's slanted? So I want it to look normal. So I'm going to say text like this, and then I'll add all other charges. So the force on one charge is the electric field generated by all the other charges. Ooh, that doesn't look great. Why does that not look good? Okay, I realized why that looks bad. I didn't include our usual math package, which handles this stuff. So use package, use math. Now let's see. Still a little wordy for a subscript, but I think it looks a lot better. So the other thing I want to change, actually that doesn't look bad, never mind. Another small thing that I'm going to do is go through and convert each of these variables into an inline math format. So like this, I'm going to add a subscript for it. And even the letters, I'm going to add inline math around them. And that improves the look of everything. Okay, so now I want to format this inline equation, and this one might be a little more messy because it's larger. So let's see what we can do. Okay, so that looks all right so far. Now let's see what happens when we add the fraction into this. And actually, I'm going to copy and paste this because notice that the subscript is inside of the bold thing. So I'm going to cut this out. And say now something I didn't mention quite before, but this is a good time to point it out, is whenever I'm adding a subscript, notice that if there's only one character that is the subscript, I don't need to use brackets. But notice right here, where there are two characters as the subscript, I do need to use brackets around them to indicate what is properly there. Okay, so it's coming along. All right, that's not so bad. There's quite a bit of space here between variables, but maybe we can fix that. Now here I'm going to add an absolute value function. But first, I'm going to actually change this package out for math tools. And that gives me a more broad set of packages that are all wrapped up in math tools. Then I'm going to use the following commands. And I think that looks uh, pretty good. Notice that this part is really just it's really a unit vector. I could have written this using a hat, but this is, yeah, I think that works well. Okay, so here's the real value of LaTeX is that notice that this equation is very similar to this equation. So what I can do is I can actually copy the LaTeX code and just modify it as needed. So I'm going to copy all of this, and I'm going to put it in an equation environment that's numbered, like so. And then I just copy my previous equation. And this looks nice, but now we need to modify it to suit what is actually there. Now here I've copied and pasted it again, and now I just can make the next line of modifications that I need. Okay, and there you have it. There, that is our first equation box, and I think that looks much more professional and manuscript, except for this. I don't like this hanging comma. Ah, I see. Here we go. Much better. Now, one other point that I'll make is when doing, now this somehow got, when I copied and pasted from Word, it's interesting how it got formatted. Notice that when you have quotation marks, the beginning and the end quotation marks actually look different. The way that it was copied and pasted from Word, those quotation marks themselves actually are formatted like that. Now, that is not something you can just type. However, that is something that you can do in LaTeX. Okay, and so the way you would do it is, I don't know how Word has these special symbols, but you would use the backward caret at the top left of your keyboard, like this, and then the normal quotation, single quotes going like that. And see, watch what happens when I compile. See, it does it right. So a point that I'll make is if I don't do this, and I just use normal quotation marks, look how badly it messes up the formatting. See, it's directed to the left. So instead I have to do these caret symbols to get it to look right. Okay, now I think that box looks very similar to what was originally here. So the second box is a small box, but this one has sharp edges. Also, we have bold text that's not inside of an equation. So there's actually one modification that I want to make to, so there's actually one more modification I want to make to this box, and that is to change the background color and make it opaque so it matches the rest of the page. So usually when you're modifying an environment, you do it in square braces like this. So I have a couple of options that I'm going to toss on here. And these are things that I found from reading the documentation of T-color box. This isn't something that I just came up with or that I even knew from memory. But if you read the documentation, you can usually find what you want. So notice when I compile, it changes it to be opaque. Okay, so now I want to replicate this square box. So the way I'm going to do that is, once again, I'm going to use another T-color box. Notice that now Overleaf is recognizing this package and its commands. So I want to add some options that will make the corners. So once again, I'm going to use the T-color package to make a box, but this time I want the edges to be straight. So notice that now Overleaf is recognizing this package in its environments. I want to add some commands that will make it have sharp corners. So let's add in some sample text here while we figure this out. So let's try sharp corners and see if that does what we want. It does indeed. That worked very intuitively. Now we just need to copy our options that we used above so that there's no background color. Perfect. Now we just need to copy and paste. Now we just need to copy and paste the actual text of the document. Okay, now we just need to make equipment bold. So I'm going to do textbf equipment. Perfect. I think that looks really good. So the next thing we're going to want to make is an unordered list. So in LaTeX, we make unordered lists with the itemize environment. Now the way this works is each item that I put in front is going to be a dot or a bullet point. So like if I say A and then B, whenever I compile it, it looks like this. So now I think we have 3 bullet points. We just need to copy and paste our text. And I got that wrong. There are actually 4 items. Okay. So there are a handful of modifications that we can make to this to make things a lot better. One, we want this to be a followable link that you can click and go to. So I need to include a package in order to create a followable link, and that is the hyperref package. Hyperref. So let's see how this works. I want to create an href. So the first thing that goes in here is going to be the address of where it's taking me. So I'm going to cut and paste that. And let's just say here, because that's how very often, that's how that goes. So now, if I click on that, it actually takes me to that link. Now, the other things that I can do for this are more formatting, make it look a little better, add the proper quotation marks that I've told you about before. Something I'll mention about units is that this does not look good. So I'm going to wrap it in a text. Okay, so let's see how that looks. I think that looks much better. Okay, so the next part of this document has a handful of numbered items. We can use the enumerate environment. Let's see how this environment looks. It numbers it very nicely like this. Now, in the original document, there's some vertical space here before the next number. Let's see if we can't add something like that. There, we've added some nice space to this list. Now let's try and make the second item look as nice as we can before we make the table. Notice that I always try and put numbers within the math environment. Let's see if we can't clean up these fractional units though. Okay, so now we're going to use a new package. This package. SI units. Let's see how to actually use this new system of units. So here we need volts per meter, and I'm going to include this whole thing in dollar signs now. So 1 volt per meter, so it can do like this. Let's see how this looks. Yeah, I think that looks much better compared to this. So let's do the same thing on this side. Very good. That looks much better. There's a lot more to this package, but in order to learn more about it, I would suggest reading the documentation. Let's change our other units that we have to that. So now we need to replicate this table. Now be aware, making tables in LaTeX can be a real pain. So bear with me for a moment. First, let's use a centering environment to make sure that our table is centered. Then we're going to make a tabular environment. Okay, so it auto-generated a small table. And notice that there are some options that come after this. So let's just compile this and see what this looks like. It's just a line. I'm going to add couple of things so that way we can see where everything is being placed. Just like this. Okay, so let's figure out what this is. So this formatting statement here at the top is saying make one column be centered, then put a vertical line, then do another centered column. So if I put a line on either side like that, then it makes it look like this. And then I can put a horizontal line by using the H line. Oh, so something else that's important that is not obvious is these ampersands are designated the start of a new column. So it goes A, ampersand, then B. And then we have this double backward slash that indicates a new row. So then let's do H line. Okay, now H line should put a horizontal line right here. Yes, perfect. And so if we do an H line at the beginning and at the end, then this is what we get. A nice little chart. Oh, that was not what I wanted. Oh, it's because we want a new line statement. Perfect. Okay, so let's build up from this. So first we're going to have 4 columns and lines on all sides of that. It's going to fuss a little. Well, it didn't fuss. And let's see where everything is going to be placed. Oh, and so I'll point out that there are 3 rows. And I'm just going to add in some random letters here so that way we know where everything is being placed. So I'm going to make one top row. And then I'm going to copy and paste this like that. Now when we build this, it gives like this. So now we just need to fill in the blanks. So now we want quite a bit of space for each of these columns that's going to be filled in. Now in order for us to do that, we're going to have to add space that is not filled by anything. And the way we do that is with H spaces and V spaces. So let's add an H space. Let's give the student 1.5 centimeters to fill in. Sorry, I meant this to be an H space. There we go, just like that. And so let's add a handful of these H spaces and see how our table looks when we do that. Now, LaTeX seems to be giving me some difficulty on this last column. It doesn't like spacing it out for some reason like the others. Okay, so I have resigned to just doing 1 centimeter, and it's still not right. Okay, so I played around with the table for a little while, and I realized, well, remembered that tables are absolute nightmares in LaTeX. So here is the best that I could come up with. I used these options to add some space. Ideally, you never have to make tables in LaTeX. And if you do, you can use a third-party software to make them for you. So I'm going to leave this as is and move on to the next thing. So the next thing I want to do is add an image like this. I'm ignoring some bottom parts because we've already done these bullet points before. But I want to show you how to get an image into LaTeX. So first, you need to save it. Then you need to upload it to Overleaf this way. If you're doing it on your desktop, the picture just needs to be in the same directory as your LaTeX file. Okay, so now I have this PNG uploaded to Overleaf. The first thing I'm going to want to do is add a new package, graphics. And that's graphics with an X. So the next bit that I'm going to want to do is use a figure environment. So Overleaf automatically adds quite a few things with a figure environment. One, it wants to center the image automatically, even though we might not want this in a second. The other thing is it adds a space for a caption and it adds a label. Now we're not going to talk about labels in this tutorial, but later it'll be for adding citations and references. So we need to include the picture that we uploaded, and let's see what this looks like. Well, first notice that it put it way down here. We don't want it there. So let's add an option. Now it's the H. Always remember it's the H that tells LaTeX, put it where I told you to put it. It doesn't like to very often. Yeah, it even gave me, it's too strict for of a demand for LaTeX. Try relaxing it by using HT. Okay. So I'm going to make it even more strict. Let's try this. Still does not like that. Okay, so let's try its suggestion and do HT. Well, we'll deal with it for now. Something that will help quite a bit is after the end of this figure, I can do a new page command. Ah, yes, okay, that's a little better. That's a little better. At least this stuff comes after the figure now. So notice that you can change the caption of this image right here. So this is my box. When you compile it, it should appear wherever you have it. You can also resize this image. However, I think this shows you the basics of how you would format a document like this. Okay, so there's one last thing that I want to show you before we turn this into a PDF, and that's that as you can see, just generating one page creates a lot of source code, and this can become extremely difficult to read, especially when you're dealing with things that are in upwards of 20 to 100 pages large. So what I would suggest doing is compartmentalizing your code into different files. Now let me show you how to do that. So I'm going to create a new file. I'm going to say section 1. Okay, so now what I'm going to do is I'm going to take the part of the code that I want in there. So let's do here all the way up. And I'm going to cut it. And I'm going to stick it into this document, just like that. Now, I'm going to do slash input, I'm going to do section1.tex. So this should compile the same as I had it before. It's just taking this code. And so it's nice because you can work on different parts of a very large document by compartmentalizing them into other files. Now, I actually need to show you how to export this document as a PDF. So you come up here to the menu and you say download as a PDF.